Right, this time, part 4 of the revision exercise using 1997 higher paper. Paper 1, 4 questions this time, numbers 14 to 17. Right, first, number 14. 14 there at the top of the page. So, pause, try it, and then check it. Number 14 then. What range of values of C makes that a circle? Again, it just looks like a circle, but you can't just put any number there. Just like when you make up a triangle, you can't say, oh, here's 3 numbers that'll make a triangle. You know, put what? I'll have a triangle with sides 4, 6, and 12. And then you start to do things like working out the angle using the cosine and reverse, and it doesn't work. Quite simply because if 2 sides are 4 and 6, there's simply not enough room between the ends, even in the straight line, to fit that 12 in, because that only comes to 10. It's the same as a circle. You can't just throw any numbers in and say, that's the form of a circle, so it'll work. That'll only work if C's got certain values, because for that to be a circle, it has to have a radius. The radius has to be greater than 0. Right, so working out what would the expression be for the radius of that. That's going to be a circle as long as the radius is greater than 0. Now to get the radius, one thing normally I put in straight away are these two centres. Centre 3, negative 2, in which case the radius is going to be the square root of the 3 squared plus the negative 2 squared minus that C. And if the radius has got to be greater than 0, that means it will be a circle so long as 3 squared plus negative 2 squared minus C is greater than 0. As long as it's got a real radius. Greater than 0, otherwise it would just be a dot. So what's that? 9 plus 4 minus C is greater than 0. Could take that over that side. And then it would read C is less than 13. I'll go through the horrors. So that makes that greater than negative 13, and then reversing the signs by dividing by the negatives, C is less than 13. And that's the answer to the question. Next, number 15 there. Question 15. A curve passes through this point and its derivative looks like this, and you want to get back to the original expression. Find f of x, it said. Well, if that's the derivative, to get f of x, that means to get f of x, I'll have to integrate that. Cos 2x dx. Maybe I'll formally identify that it's a function of a function. So I'm going to differentiate, integrate that. The cos will come back to sine, so it'll be the sine of 2x. If you were differentiating this, you'd have multiplied by the 2. Integration is the reverse process, so it'll be divided by 2. So I'll just put that down as times half. And then plus c. So I've got that. F of x is a half of sine of x plus c. Then you get this information. It passes through this point. When you put 1 in for x, the answer turns out to be, when you put pi upon 2 in for x, the answer turns out to be 1. So that means a half of the sine of 2 times pi upon 12 plus c should come to 1. So what's that? A half of the sine of pi upon 6 plus c should equal 1. So it's a half of, and then this is in radians. That's actually quite handy because it means I don't need to put all these tiresome degree signs in. Radians might be nasty, but they save you having to do that because that's perfectly correct, putting just x in its own. Not being lazy this time. Pi upon 6, but I'll still do this. I'll still think, what's pi upon 6? If you change that into pounds, shillings and pence, that's going to be 30 degrees. Now, if you don't remember the sign of 30 degrees, you can quickly draw the little triangle, half of that equilateral triangle. Shortest side, 1, 2, root 3. Sine, the side without, sine the angle. The side without the angle, so the sine is going to be a half. So it's a half times a half plus c equals 1. That's a quarter. So c is going to be 1 minus a quarter. So c will be 3 quarters. So for the final answer, f of x is going to be a half of sine 2x plus 3 quarters. Next, number 16, sketching transformed graphs. Question 16. On this diagram there's a graph of y equals some function of x, and it names a couple of points on it, just in general terms. Make a copy, done that. sketch the graph of y equals g of x, where it says g of x equals f of x plus 1. Well, those are alterations taking place after the calculation has been done. So these are alterations to the answers. These are alterations that are going to move it up and down the way or expand it up and down the way. This is an extremely easy one though, because what does it say? If it just says f of x plus 1, if that's f of x that looks like this, just to put it in very quickly, then f of x plus 1 is just going to shift it up 1. Minus 1 would shift it down 1. If the alteration had taken place inside the brackets, the answers would have stayed the same, but they'd just moved to different positions. If it had said f of x plus 1 in the bracket, then all the answers would have moved, same answers, moved back 1, and so on. So when drawing this graph, another thing too, when drawing this graph, you're not actually going to draw like a parallel curve around it. You'll notice that when you do move that up, these points may move apart, but anything that's steep actually begins to almost touch again. So moving it up 1, it's just roughly anyway, it'll be something like this. I should have drawn that different colour, I intended to. So there's y equals g of x. Just put in those 2 points. So that's still at 0, but it's going to be one. Answer is going to be 1 higher. So 0, a plus 1. And that point is still going to be at b. There was no alteration inside it, but the answer is going to be 1 bigger. So b, a, c plus 1. Okay, that was the first part. And the second part says, on a separate diagram, right, there we go again. On a separate diagram, sketch the graph of y equals, only this time to draw, y equals the derivative of f of x. Well, the derivative means I have to draw the values of the gradients at each of the points. Well, on the original graph here, there was a point of inflection, that was the point A there. A point of inflection was meant to be on the y-axis, so that means the gradient would be 0. There's a maximum turning point at B, so at B the gradient would be 0. Then it's just a case of what happens before. It was rising until it got there. That means there were positive values of the gradient, but they were tailing off, getting less and less until it became 0, so it's going to come down like this. But after that, it continues to rise, so it's to be positive here and positive here. And then after B, I should have negative gradients. And then I've just got to put a curve through those. So it must sort of come down. It won't be a cusp, it must be a smooth curve. I'll have to come round and then drop it back down again. Maybe I'll have to shift that B over a bit. And then for part C, it says, describe how the graph of y equals g dashed of x compares to f dashed of x. Well, all you've done is shifted them up, it's not been stretched. The gradients will still be the same. The gradients along f of x and the gradients along g of x are meant to be the same, which means that the graphs would be identical. So it's just a case of how do you want to draw that, write that out. How's the graph related to? So we just have to say this. The graph of y equals g dashed of x is identical. Not been moved up or down, it's just the gradients, and the gradients will still be the same because there wasn't any multiplying number that would have stretched it and changed the gradients. Is identical to the graph of y equals f dashed of x. So that's that one done. And the last in this set, number 17, a nice wee loggy question. So, 17. Right, part of the graph of 5 log 10, 2x plus 10 is drawn here. It crosses x-axis at A, it crosses the line y equals 8 at B, and you defined algebraically the coordinates. So you can't do anything like saying, well, it should cross at 1, so it's been shifted back a certain amount. So algebraically means I'll have to use the equation and substitute in values. Well, first of all, where does it cut the x-axis? Well, any point in the x-axis is going to have a y-coordinate of 0. That's a coordinate equation. In order to use that equation, I'll need to know one of them to work out the other. So I know that at A, y equals 0. So you put that into the equation. So that means 5 log 10 of 2x plus 10 equals 0. And then there's x to find. So that'll be easy. There's only one mention of x. So you can get x just by digging down until you get it. Get rid of the 5, get rid of the log 10, then get rid of the 10, then get rid of the 2, and you'll be left with x. Right, so how do we get this potato then? Let's get that 5 over. Well, 5 over would just divide into, that would just be 0. Or you could say, well, if 5 times something makes 0, and 5's not 0, then that part must be 0. Either way round, log base 10 of 2x plus 10 is going to equal 0. Right, get rid of the function log base 10. So carry out the inverse operation on both sides, so that will become, instead of log base 10, it'll be 10 to the power on this side, so 10 to the power 0, which of course is just 1, to save another line. So 2x plus 10 equals 1. So 2x is going to be 1 minus 10, which equals negative 9. I'll just put it here to save another line. So x is going to be negative 9 divided by 2. So if it says, and what's the coordinates of A? I'll have to formally state that, yes. Oh no, just the x coordinates of A. So that's it. The x coordinates of A, so that'll do for that part. The x coordinate of A is negative 9 upon 2. Now what's the next part? B. So that was for A, I did that. So to find B, again, to find the coordinates of a point using the equation which connects the coordinates, you need to know one of them to find the other, or some connection between them. Well, on B, since it lies on y equals 8, y equals 8. So at B, y equals 8. So off I go again with this. So I've got 5 log 10, 2x plus 10 equals 8. Right? There's only one mention of x. You can dig down and get it. Get rid of the 5. So dividing by 5 makes it 8 upon 5. Remove the function log base 10 of it. So apply the inverse, which is 10 to the power. So it'll be 10 to the power, 8 upon 5. Remove the 10. So x will be 10 to the 8 upon 5, subtracting 10 from the both sides, minus 10. And lastly, divide by 2. So that's 10 to the 8 upon 5, take away 10, divided by 2. Hopefully this will show, or maybe I've got room over here. Now you can just do that in your calculator, because the opposite of the log button, log, is the 10 to the x button. So you just enter that in as shift 10. So you enter that all in, and there it is. Answer comes out as, we've got 14.905, so 14.905 ... which means x of b is going to be, just call it 14.9. That's the end of that question.